From this point on, if we're going to say a modern model, it has to do reasoning from now on. Basically, that's just, you might as well just start asking for that.
Welcome to episode 17 of Tool Use. Tool Use is a weekly conversation about helpful AI tools where we teach you what is possible today with the help of industry professionals who share their knowledge, insights, and real workflows. Today, we're joined by Nisten, and if you're on Twitter for AI, you definitely know who Nisten is. He works with Alignment Labs, with Skunkworks, and he's going to share some great things. I'm Mike Bird, talking to Ty Fierro. Ty, how you doing?
I'm doing great, man. I'm looking forward to this one. Should we just hop into conversation?
Let's do it.
I'm Nisten Tahiri, and I live here in Toronto, Canada. I do a lot of open source stuff. I used to post a lot more models because me and Farouk ran Skunkworks together, which is like a pretty big Discord group, and made the first mixture of experts MOE, like the first open source one before even Mistral had released one. And we also made the Baklava model, and then ended up doing contracting for a while. So haven't posted as much, but have some pretty exciting stuff, both open source and not open source coming up. So I'm here in Toronto. I mainly work with I do contracting with Alignment Lab, so that's how we do jobs for other people to pay the bills. And I myself work on Raccoon AI, so we're making a mobile operating system. So it's a completely from scratch operating system. So not Android. It's just plain Linux. Even the kernel's custom. And that's been working more on the interfaces side, because I feel like that is lacking now. I think the models are pretty good, and yeah.
And where did you even begin to approach doing the operating system?
Well, I've used Linux since I was literally 13, when we had to set up Counter-Strike servers, and you just find like a box off of someone's side. Like you just go to like a rich neighborhood and just grab whatever computer boxes they have, and you would just run like when we were in high school. They weren't enough to like really game on, but they were great for servers. So that's how I started out. And I went to University of Ontario, so I did network engineering and IT security. It was also a very computer science heavy program. I had a pretty strange coming into the whole AI field, because at first I was doing security audits. So I was doing like DevOps security. You get like a whole bunch of like financial officers, and you have to go and basically try and hack them, but in a professional way. So you had to write a report for each one, and I absolutely hated that kind of work, because nobody cares until something breaks, and until you miss. So then I went to do TypeScript and React development, because React came up, and so I did that for like a good 5 years or 6 years, and then a friend from school just got me to go when I no longer had a job. To just go LARPing and do look at AI stuff, because I never really cared. I mean, there was the whole corporate ML stuff where they just check if somebody bought stuff on a shopping app, or like what the regression models is, but I never actually cared. I had to implement them. I had to give them their data, but never really bothered to do it myself. And then I ended up in the AI field for the last like 3 years. Yeah.
Was there a moment that like made you fall in love with AI?
I did the NASA hackathon in Ontario, and I made like a little raccoon assistant. So by the way, my shirt is raccoon. It just says meow. And this was about and we won that for the first round for the hackathon, and it was supposed to be like a scientific assistant for like the International Space Station that just gave you stuff from the ISS, like technical. It recited technical documents for the ISS. It never actually worked. It was just like way too ambitious. I was using the web speech API to have Raccoon as the keyword that activated it. And then I had no idea how to do the search for the actual technical documents to show up. And then a month later, the ChatGPT came out. So, so all of that was like, oh, there's a lot we already can do here. This is just, it was around that time. So again, I had it pretty weird. I had to do TensorFlow, JS first. That was my first book on LLMs that I actually bought. Again, it was from the web side. And then I'm like, oh, okay, I actually have to do Python now. All right, fine. It was mainly the moment when it just went from, this is no longer just GPT-3 writing your security policy documents for some startup, but it was like, oh, this can actually talk. So that was the main big thing. And because until then I only thought, okay, these are just tools and it's never going to go anywhere. And I mean, I'm still going to use them and implement them. I've been doing it for years. But then all of a sudden it's like, whoa, this just there's something else now.
And what drew you to like small models?
Well, at first I worked on the API side because I was doing I was doing a lot of medical AI work. So one project was for an ER clinic. So like was one of the first to fine-tune Whisper to be able to have like better hearing in a hospital to just like better transcribe stuff. And then working with healthcare companies was just complete hell. It was fine to talk to a doctor and then get feedback from them. But then they're like, okay, can you show up at the clinic? I'm like, yeah, I can show up at the clinic. I can just go there. I'll stay for 3 days. I'll bring my health card. It doesn't matter. Like, we'll figure it out. And then there was just like this whole layer of bureaucracy and everyone wanted to have a say in the beginning. So then I got pretty fed up with that. And I went on to work for literally the most hated person in the industry. So I just to prove a point. So I went to work for Martin Shkreli, and we made Dr. Gupta, the first doctor rapper on the market, like the first commercial doctor, and that was like a year and a half ago. And and after that, I saw that it was still having a hard time picking it up. People were quite worried. The episode was great, and I put on everything I learned before to anonymize all the data. So even if I got hacked, they couldn't really see much on the AWS because it was all hashed. But then I found that people really need local small models. And from that point on, I was like, okay, I actually need to learn the Python stuff and need to start learning the training. And that was the time when I really got into all the Discord groups and stuff and started to train models. Up until that point, I had no idea. There were like very basic terms that people would ask. I don't know if it was like regression or like what's a model, stuff like that. I'm like, okay, yeah. So the small models were mainly because you can iterate on them very fast, and you can try the new techniques very fast, with the idea being that you would always end up training a larger model. But if your data and stuff doesn't show something to be good on a smaller model where you can iterate, there's no point just going straight to the large one. At least I thought. For bigger companies, it's different. They can just go all the way at once. It's a different story, but yeah.
Where are small models most useful nowadays? Like, why would you reach for a small model over the bigger models? Yeah.
Well, that's a big question about small models. I would say if you actually measured what they're used for, it would probably just be for censorship. I mean, I say censorship, but just content filtering on sites. So stuff like, if you go on Cloudflare and you're going to upload something, it's going to check the pictures that they're not like abusive and stuff. So that's a small model running to do that. They don't send that over an API. They run that on their own. So that's I would say that's the main thing is they're really good at content filtering, and that's been the case for a while. Recently, if you saw ones like Gina, the Gina 0.5b, that one is super fast at just taking the dump of any website, taking the index that HTML and generating XML data from it, and it does it with like a higher accuracy than GPT-4o because it's literally just made to format XML. It's not made to be smarter or anything, and because it's a 0.5b, it's crazy fast. 0.5 VC, you can get over 1,000 TPS these days. So I'd say those are like the two actual practical ones, and the rest are what people are trying on devices, which hasn't really been deployed as much. Although you could argue that the small model that is inside Chrome right now, I think is the Gemma 2B ships with the newer Chromes. That is a very large deployment because it's in all the Chrome browsers, and there was some controversy over that. But you don't really see used as much. Oh, and the last one where they are used are for, let's not ignore Replit. Replit runs their own tiny small model to do all the inline help. So yeah, that's where they're at now, mostly just used as tools rather than people talking to them. Although there are some projects that they use the 7B, like the Bud E project from Christopher from Lyon that's been deployed in German high schools. So I think that one is a 7B supposed to be kind of assistant. And yeah, they're not really used as actual chatbots.
Speaking of Replit, do you use any coding assistant tools like that or AI tools in general in your workflow?
I don't, and I don't use them because they're bad or anything. I started off with the very first codex, so with GitHub Copilot as soon as it came out. I also used Amazon's Code Whisperer as soon as it came out because it was free for any AWS account. And then after a while, I felt like, oh, this is just making me forget what I actually have to do. And I think it was during an interview or something where they just asked me, okay, just code something. And then I'm like, oh, wait, hang on. I can't just tab and stuff. Like, I just have to remember this. And okay, this is making me forget. It's like when you use a GPS or you keep looking at the map in a city, and it could be the city you live in, and then you forget where you are. You know, I've been coming here for like 20 years. So that's why I stopped using them that way. The way I'll use them now is I'll just put the Llama CPQ web interface on the left, and I'll just have the terminal on the right, and then that's about it. And I'll just use the Z browser, or I still use VS Code because VS Code Live is such a useful feature for boxes, mainly because it opens up a tunnel. And lately I've just switched to just using plain Vim. And yeah, it's not because, again, there's nothing wrong with Cursor. Cursor is great. I just see that as this is your like retirement software. And I'm not ready to retire. Like, I still have a lot to learn. But once you're experienced enough, and you've done stuff in a couple of languages, and you've built some large projects in a couple of languages, and you overall know what you're doing, then yeah, I feel like it's great to use to start automating. But until that point, you should not. At least that's my opinion on it. Again, people have to complete stuff on the job, and they have tasks that are due the week off. So like they'll have to use it. Then there's not that much of a choice there. But if you can avoid it, Yeah, so I don't use inline code completion. I probably should know because Georgi Guganov released a Vim plugin and a NeoVim plugin for Llama CPP, which does offer inline completion. So now I'm like, oh, okay, I actually have to use this. But overall, I've been focusing on long context where I just dump in the whole thing, and then I just use the chatbot as an assistant. Like, just hey, tell me what about this and what about that, and then I'll look stuff up, and I'll try to actually like type it all in, so that it's the muscle memory tells you what you're doing, and you actually remember the code base.
I've been noticing that with my own workflows too. Just like I've used a lot of Cursor. That's my go-to tool. But I was on the light rail the other day, the subway, and I didn't have any internet, and I had my computer out, and I was like, I'm just gonna code something for, and I was just trying to code, and I was like, am I dumb now? Did I just forget how to make a React component without hitting tab or asking Cursor how to do it? And so I don't know. I think there's definitely something to going back old school and trying to just code the old fashioned way. But okay, you mentioned long context. I know that like Google's got long context, and I'm sure long context windows are coming. What does long context windows look like in the local LLM space? Is there a timeline for that type of thing? Is there technologies that are holding us back? Or
Oh, they're already great. They are fantastic right now, up to 128K. There's the Quen 1 million, which is I think he mentioned. This was only mentioned on Thursday AI, so I can say that actually it doesn't matter, but that it was an MOE model, and this is an MOE that they have not released, and it's mainly because for such large context windows, you need to be able to still have a large model, so the memory can be accounted for, but because it's an MOE, the number of active parameters can be small, so your limiting factor, it's not even actually memory, although for single GPUs it is. The limiting factor is how many active parameters do you need to compute on, because a transformer does not scale that well. It does not scale linearly for the amount of context. It gets progressively slower the more context you add. So even if you try like the GLM 1 million model, which is a 9B, which is normally going to be super fast on whatever you run, it's just a 9B. You can run 8 bits very, very fast, like over 30, 40 tokens per second. Once you go above like 600,000 tokens, it drops down to 2. So now you're at 2 TPS, and that's just a 9B model. So you want to, if you're going to run something, it is very good at that. Like you can recall stuff perfectly, especially for stuff like, oh, I want to run this, I don't know, maybe you have this class or whatever, you have like an older code base, and you want to say, hey, can you reference me like which part of the code base this, I don't know, this thing like pulls props from, or wherever it is. If you have all of that in context, it will give you perfectly what it is versus having to play the lottery of a RAG system, of a retrieval augmentation. So for 128K, this basically, I only use the local open source models at above 40K in context. So I always start them off with at least 40K of context. So that could be the 14B Quen or the 32B Quen or the QEQ. That's what most people use right now. But I also use Mistral Large often to mainly to like write really long documentations, because Mistral Large is very good at outputting more than 32K at once. So if you have like this gigantic dump of a chat and you want to say, hey, write out everything that we did here, remove all the duplicates, and then document everything in accordance to everything else we know about this code base, Mistral Large, while it might not necessarily write working code, it will document it perfectly, and it will rewrite the whole So now you end up with a much more refined, longer context stuff that then you just feed into other models. And you can also do this in Sonnet, and you will notice that you very quickly run into the usage limits. I went on a whole rant about that, about the Sonnet usage limits, because you literally just use it, right, 25 minutes, and then you're done. You have to wait for 3.5 hours. So yeah, honestly, I think that's going to be the way to go, and it's just barely gotten started. If you just have one file, if you just have the actual Llama CVP file, it's already over 1 million, like 900,000 tokens or something. No, it's already like 800,000 tokens. So there's just one file. So if you want to dump that in and just be like, oh, this is a very long C++ file, and I want to do something where I do custom inference. I want to just repeat some layers on the fly, or I want to, I don't know, quantize some layers and then run some tests. If you haven't worked with that code base, you're not going to have that in your head. You don't know where everything is in like what is it now, like 1,900 line file or more. I can check what it is now, but yeah, if you have something that large, you don't know where it is. If you can dump it all in context, now you have an actual assistant. That's how the models are supposed to be used. Now I can tell you, oh yeah, you go here, you go on this line, that's where you added this, and then you go here, that's where you added this. And okay, now I can kind of figure out what to do. And that's honestly that's the way I see them, because otherwise the only other option you have is to train it, and that's a very expensive option. And so there's a lot of questions around that.
Definitely. And I saw one of your posts a while back when you advised people to get this very long tokens or very long context, spend a couple hours, write out the message, like really think it through, race through instructions. So when you test out new models, do you use a standardized way of testing to see if it works for you, or do you just take your current issue and try to give it? Do you like an eval type thing? Do you try to do consistently across new models, or do you just test it based on your current needs?
Well, I run the eval. So mainly I run MedMCQA, I run GPQA timeit usually. Those are the two. Like I check for medical just to know, because if a model is smart at everything, it will also be pretty smart at medical stuff. And then I try I just try 1 or 2 vibes-based questions. I don't use the strawberries and stuff anymore. I just do the Martian question, where it's like a very long multi-step question that I always use. I've posted a whole bunch of times, where you say, oh, you have the highest mountain in the solar system, and it's on Mars. It's Mount Olympus Mons. If you were to build a maglev train on it, and on the maglev train you would accelerate at 2 Gs, so you're still kind of comfortable. How long would that rail track need to be for the maglev train to be able to get to orbital speed? Then you say, how long would the rail train need to be for the maglev train to escape the gravity well? And the reason that it's such a good question is because there's so many steps in between that you can just say, well, what about 2.5 Gs? And then the calculations, it has to, like, there's no way for it to, I mean, pattern matching helps a little bit, but it's pretty hard to cheat that as a benchmark, because it has to think all of that through, and it has to get within a certain margin of error. And you actually do see them hit that margin pretty well. And you'll even see some variances, because they say, well, do I want orbital speed right at the height of Olympus Mons, or maybe do I want to be like a little bit higher to just be safe and not have any atmosphere at all? And then that number will just be slightly larger rail. So I use that, and I run GPQ Diamond just because it's only like, I think 1,400 questions or 700. I forgot the ones, the main, the other ones, the Diamond. And then I just do like a code base dump. Yeah, so mainly I do the documentations from the Gleam programming language because it's just so small and one person wrote it that you can just fit all the docs in like 60K of context. And then if you go to 100K, you can even fit in almost all the standard library. So you can fit in the whole language, the entire std lib, and all the like the handwritten tutorials, and you can fit that in 100K. And it's one of the like the only language that you can do that. And most models are not really trained on it at all. So that's how I test. Is this a good reasoning model? Because I can just dump in everything from this language, which I know it's not good at because not even Sonnet or GPT-4 can write working code in it. And then if all of a sudden this just writes like a syntax highlighter or whatever as a test, then I know, okay, yeah, this is a good model. So it was from that point that I realized, oh, well, handwritten documentation makes such a big difference versus me only dumping in the standard library and then some Sonnet chat that I had about it. And then it doesn't fully get it. But when you write like actual handwritten docs that a developer wrote about this language, it's like, here's the tutorial, here's what you do, here's what you do if you're coming onto this as a TypeScript dev, here's what you do if you're coming onto this as a Rust dev, as an Erlang dev, this is how you use this language, and blah, blah, blah. And then it's super smart all of a sudden. So it's like a form of, you could say, in context learning, kind of, because you're not really training. But look, when you do that, it still takes up like 30 gigs. So the model itself is 32B. And then you add this whole context file. So there's just like a 30 gig chunk or a 34 gig chunk of neurons that they just dumped in there in the KV cache. And it is a lot smarter after that. So like it would be a lot more efficient to have it trained and then run it. But if you're just going to inference it on the fly, it's actually a pretty good method.
But there's more things like that out there to test these models on. I don't have my set of like little evals that I run on each little model that comes out. I'm trying to develop that. Each guest we've had has a different approach to it. It's really cool. Something that's really interesting to me right now is I have a lot of hope for distributed model training. I think it's kind of cool to like share GPUs across the world. Do you have any thoughts on that? I've seen that like Prime Intellect is doing with like distributing model training, where you can have a bunch of computers like kind of work together to train models, but I don't know a lot about it. Do you have any thoughts on that?
Oh, okay, yes. So Dr. Colin Raffel, who now moved to Vector Institute in Toronto. So he was the one that actually called me. I think like 2 years ago, he wrote a paper with Andrei Borsunov that wrote the Petals protocol. Andrei Borsunov is based now in Georgia because he escaped Russia, did not want to go in the meat grinder. And but anyway, so Borsunov wrote that whole Petals protocol is based on his Hive optimizer, I think. And so if you look at OpenDeLoco, and also if you look at Nisten, they're all builds of that code base. Like that's all Borsunov's code in that. And yeah, so that's all from, and Petals was built off of that. So that's all another build off of the Hive mind. And there was also something else by the DeepSeek team where they tried to like when they were doing distributed training and they only had H100s. Now they have H100s. I think someone reported. Apparently they have like 10,000 of them or something, or 50,000. So those got smuggled in. But what the main thing about distributed training is that you're bandwidth limited. Like at the end of the day, it is just like how much bulk of data from your gradient or your chunks and whatever else is going on in there, are you moving in between the GPUs, and because they need to see, that they need to match, they need to compare, and you can only do so much. I mean, you can still do a lot. You can get a whole order of magnitude of improvement, but then that's about it. Then you're limited. So if you see something interesting about the H100s and the NVIDIA NVLinks, was that when you do actually end up chopping up the bandwidth, you only end up with only 600 gigabit or so in between the NVLink switches. And then you look at the Meta and Facebook, their infrastructure document, and they moved away from that, and they just moved to like plain Ethernet, RDMA, remote direct memory access. And that one, I think they pair 4 cards that are 100 gigabit. So they have 4 ports per GPU. So each GPU has at least a 400 gigabit Ethernet mapping. And then that 400 gigabit, they have dedicated fiber, multiple terabits of fiber in between their data centers. And that's how they say, oh, well, this cluster is just like, we have just about enough GPUs, but not enough. So we need like 10% more. We can grab those 10% more from the other data center and form one virtual cluster. And Google does the same thing, just way more advanced of a manner. So you can do distributed training. It's just that you're very, very bandwidth limited, especially if you try to do longer context or go up. Now, that doesn't mean that it's inefficient to go up. It just takes longer. It just takes longer to transfer the data. So again, with OpenDeLoco, which is what Prime Intellects is, they built the optimizer around that. So they improved the optimizer. I think Sandra is pretty cracked. Then I looked at that project. I looked at it for news as well, because I also wrote. I didn't write. I implemented the Grok optimizer that Eric Hartford had first implemented from the paper, and I implemented with the Biggie Small model. And I was trying to implement it for a distributed, and someone from Torch said, "Oh, just use there's like a new Torch AO distributed that makes it pretty easy." But it's just a lot of work that I just didn't want to do it. Basically, like that just requires someone to be on that 24/7. And the meme with the guy shoving one more thing in his brain, and he's just saying something about the Atom optimizer that it can't do. I forgot what it is. Yeah, you need to have all of that in your head. So if you're gonna do distributed training, that you can't just go and do other projects, in my opinion, because you're just not going to have enough space in here to fit that in. Like, you're going to run out of ramp. You're going to biologically.
Yeah, we're all rate limited. And Noose just finished their distro run, so they said they're going to have a write-up soon, so I am eager to see the results on that. But you're right. We can only focus on so much, only so many hours in the day. What technologies excite you the most right now in the space?
It's actually the raw computer use ones from so you have the I actually haven't even tried it myself yet, the one from Sonnet from Anthropic, where it fires up a virtual machine and actually uses that. The reason I like that over the other model, I think from the French company Hive that they released, was because Hive was it would just look through the DOM, the document object model, and it would do the tree traversal. So I think they had trained they trained it to just be able to just grab the window objects from the browser and actually traverse through it and then be able to like tell the state. So it's like they're doing a neural redux, but not that advanced, but because they did it that way, they could just do it with way smaller models. I do like Anthropics better that it is a raw video picture of a virtual machine, because that can work with anything. That can even literally work with like a COBOL mainframe, and like it'll figure stuff out. All you got to do is give it some way to click, right? So I, because I think that's what's missing, right? It's true. Doing true automation is very hard. Like you can make pasta at home, all right? Like and you can make good pasta at home. You can even like make the pasta at home with like a little roller thing. I don't do that. I'm just saying. Uh, but have you seen the machines that like mass produce pasta? Bro, that's a freaking like that's an assembly line. That's a dude. That's a massive multi-room contraption, like over-engineered and everything. It's still just making the same stuff. And so this is the part that people don't realize as much. It's like, oh, okay, yeah, this can automate. You can make your fucking pasta at home, and it seems like, oh, you're not making each strand by hand. You're making a couple. But no. To move to like real automation, to like real mass production, that's going to be a whole other magnitude of complexity. And it's going to require a lot more compute. It's going to require a lot more efficiency at the same time, and more compute at the same time, and better chips, and better models, and faster inference, and overall visual tricks, and the tiny visual tricks, and it's going to end up being bigger. So that's the part which I find that people don't realize how much more freaking work this is going to be. So those tools kind of excite me, because I'm starting to see the pieces of the big pasta machine, like the gigantic thing. I don't know. I'm obsessed with those videos of manufacturing stuff, like the real life Factorio videos. It's these tools that I find are gonna be the next thing. So yeah, don't worry about lack of employment. It is just gonna get harder to hire, dude. It's just,
It makes a lot of sense. It kind of feels like that is kind of the grand prize of AI, is like getting to that point where machines are completely automatable, and these can control computers as good as we can. I mean, I've spent a lot of time in that space at Open Interpreter, and it's been really fun to play with. And I know how hard it is, and it's going to take multiple different modalities and a lot of different technology to get there. I'm excited to see what OpenAI drops, their Commander thing. I mean, I don't know if that's just Twitter rumors or whatnot, but we kind of have to see what that is. But yeah, I think it's an exciting world out there in UI automation and operating computers. I think that there's a big world out there for that. But I think another thing you mentioned too, like, yeah, you can make pasta at home, or you could just buy the stuff that's store made. That's like, a big company makes. I feel like there's a little bit with that with like model training, why would you train your own little model at home when you could just use OpenAI's models? Yet there are people that can create these small little models that are incredible. Like one of my friends, Vic, made Moondream, and he just made it in his bedroom, and he has a little set of 8 GPUs at home. He trained his little model for image understanding, and it is incredible. It's this teeny tiny little 2 billion parameter model that competes with the big models, and he made his pasta at home, and it was almost better.
I mean, it was better. Yeah. It could do, Moondream can do text recognition a lot. Actually, I think better than GPT-4 in some cases. It was actually scoring. There were certain parts that the old Moondream, even if you run it in as like the 1.2 gig, like 4.5 bit version, that can score very well. So I mean, yeah, there's you do have a point there, but again, people can make stuff, and they can make gigantic things. I mean, it's gonna get harder to do the data pipelines, especially given that like right now you got to do I don't know, like, what was the requirement? It's like 13, 14 trillion tokens for state of the art model. If you're if you're going to make a state-of-the-art model, you're going to need over 10 trillion tokens. You're going to need to filter them and topic model them and map out what parts they're missing in the distribution. And you're going to need multiple pipelines for like creativity, code, math, science, poetry, multiple languages, medical, all that shit. And it does become a lot of work. Or you can just go to your local burger shack and just get. It's gonna be more expensive to make it on your own because GPUs are expensive. But yeah, if you look, however, also Wolf from Ravenwolf, he posted a lot of the benchmarks. The newer however you pronounce it, it's like the delta now. It is so small. Like even if you just do all one sonnet, Q, and maybe like a coder with a long context window, because I do use them. I did buy sonnet just to compare and stuff, and just to be mad about the limits. But if you see like the delta of you using a modern coding model, like, or if you try out DeepSeek with the reasoning, like if you use a modern, and by modern now I'm starting to mean reasoning. That's where we're getting. Like from this point on, if we're gonna say a modern model, it has to do reasoning from now on. Basically, that's just, you might as well just start asking for that. And if you look at that, using something like that versus not using an LLM at all or just Googling stuff, it is such a huge difference. Whereas if you go from Sonnet to O1, like, do you notice a difference? Not really. At this point, I think like there is a case to be made that it's better to just use all three of them and just have them all going at once, and then you getting back what comes. But they're also none of them are that good yet, because they require multiple passes to actually get something to work, and you still need to think. So we're not really at the mass production stage yet, I think. I am surprised that open source actually got this close, and in some cases now even surpassing it for certain tasks. But they are hard to use, so the usability angle is pretty messy. Like I could show it right now, but then we'll have to wait like 5 minutes for it to like warm up with the context and stuff. Like it's really cumbersome to just fire up an open source tool with longer context. I mean, I do it because this is what I do every day. But if I think of, hey, I'm gonna recommend this person who is a statistician or an accountant, and they want to use, I don't know, this accounting software, and they have a whole bunch of documentation on that. How do I tell them to, well, you have to cache the context file first in lambda.cpp, but and you have to run it with speculative decoding because otherwise it's like too slow. And so you got to start with the server and you got to do this command. But then like if you run out of memory, maybe you should reduce the KV cache to 8-bit or 5.1 bit, and then test that and then see how that works. And then they're just going to be like, what are you talking about? So the usability side, I think people are not putting enough. I mean, you guys are, because you guys worked on Open Interpreter, but I think in general, people don't realize how hard that is, like to actually just like make a finished packaged product. It's a lot of complexity, because again, you can go to the local deli, you just get it in a plastic bag, and you're gonna have to cook it in 2 days because otherwise it's gonna go bad.
Just on the note of like local models and fine tuning, do you use any tools or framework like Unsloth or OpenPipe, or how do you go about fine tuning models?
Yeah, I use Unsloth usually, even just in the free collab, just to try out the data set. So just like with the 7B, just to see, oh, does this work? Or does this actually make it any better? Does this actually train? But then afterwards, I no longer I no longer use that. I've started to use Torch AO, so Torch/AO a lot more. This is like the advanced research division. I don't know. That's probably not the right way to put it, of Torch, but I think they're just now got like full FBA training to run end to end, because before it still had to upscale to float 16, but now they can actually do like proper 8-bit. They cannot do proper 4-bit training yet, so there's no 4-bit training. So I will actually just use plain Torch script in Tmux in Python to do the bigger training runs now, mainly because you run into hardware limitations. And so that was just the most recent. I'd say the one I've used the most has been Axolotl. It's still, if you have multiple GPUs, you're going to use Axolotl because you already know the accelerator setup. You already know it's going to work with multiple GPUs. You already know it's going to work with multi-node. So if you have 8 or more than 8, if you have a multiple box, you're just going to use Axolotl. Don't do that on your own. If you only have 8 GPUs and they're all in the same box, you can do that on your own. So yeah, that's my go-to. Try it out in Onslaught. Get an Axolotl container going, because with Axolotl you can have a lot easier time doing multi-node. And beyond that, I don't know. I'm not the right person to ask about like Triton and running tensor, because that's just much larger scale, which I've never really touched beyond 32, to be honest. So if you're gonna go like a couple hundred, you need a team at that point. That you're not just gonna do it on your own. Yeah, that's the thing for training. So we are doing training now for some clients with Alignment Lab, and Alpin and Austin Automata on Twitter are helping out with that. So some is stuff like it's like an enterprise tool, and they have their own language, and they just want like a small model to be able to write queries in their own like proprietary tool. And they don't mind if the model is open source, because they don't care. It only works with their tool anyway. So that's there's been some cases there. The other one I'm doing is for the Danish municipalities. So they want like a nursing bot to be trained for each municipality to be able to recommend to people where to go. Like, hey, my grandma fell and she can't really walk that much anymore. They'll be, oh, well, your center is here, because based on like where you're opening this chatbot from, we route to this model. And the reason that you use local models for something like that is because it doesn't need to be a complete genius. It can be very close, and it can be trained specifically just for that, which makes it very unlikely to hallucinate anything in tests, because it's not going to suggest 911 anymore, because they don't have their Denmark and they don't have 911. So that's one thing where you kind of need to train it, and you need the training because it has to be a small model for you to be able to serve it. And this also complies with older laws, and you don't have to worry about GDPR and stuff, because you just don't store the data in the first place. It's just like on that instance, you're not sending it anywhere. You don't have to clean it up, because you're not sending it across the continent. You're just not even saving it at all. So yeah, those are the main cases for an actual small model. For the doctor and stuff, if that project goes through, it's going to be much bigger, because that needs to like perform well. And for that, I've made like a custom ADB model that we'll be releasing, is just built off of 2072. So yeah, I do see the use in that regard. I'm a lot more excited now what's going to happen with the tiny ones on device. yeah, I do see the future in the tiny models. And I don't think the delta is that big overall. Honestly, I think when you look at the newer reasoning models, even the one that Pharrell and Ruli had made, the 8B, how well an 8B can perform with a reasoning engine, that tells you where we're at now. Like the moat has kind of dried out.
Wow. Yeah. There's a lot to unpack there. They've got lots of homework now. I need to try out some of these different things.
Is there anything else you'd like the audience to know?
I do have two things coming up. One is openhospital.ai, which is not up. So this is part of the Danish initiative. So I'm going to be releasing a model there that you can in theory run on your own, but it's like an ADB. It's pretty large. But I'm going to be releasing a healthcare model. Also have a very high-ranking base model, and the stuff for Raccoon AI, the Linux OS. I don't think it's ready yet. Although apparently someone saw my post about Hannah Montana Linux, and they were like, "Oh, I grew up with Miley Cyrus. Like, do you want an intro?" I'm like, "I'm not sure. I want to get sued." That's all. That's all I have to. I don't have anything to sell at the moment. I mean, we do contracting for Alignment Labs. We make models for other companies. If you have some like corporate needs that you do need to train your own model or make your data set. We also, I think the guys made a data set for Unsloth before and for Liquid AI, and that was Austin's big effort there. So made a whole bunch of Liquid data sets. But yeah, that's how we pay the bills. We make data sets and sometimes train models for other companies. So.
And I got to recommend everyone check out your Twitter too. Great rants, good insight, lots of alpha.
I don't filter anything I say because I'm not really beholden to anyone. Like I'm part of an open source group and have my own corporation, so I don't care. It's not going to be filtered. You might not like what you think. It's not even monetized, so I don't. It is what it is.
Yeah, it's pure, and that's what makes it so good. I think it's just you sharing your thoughts.
I think more people should just do that. You gotta get a wider distribution because if everyone tries to sound correct to you, you just end up with collapse and logits. So you're the output variability is not going to be that good. So I think more people should. Speak their mind. It just makes for better training data at the end of the day. And I'll just leave it at that. It was great talking to you.
Yeah, really appreciate having you on.
It's been great. I have lots of stuff to go look at now.
It's been great.